Hello class, welcome to this lesson on 1.7. So we're going to break this lesson into two parts here. So we're going to cover part one here for writing proofs. So proofs is a lengthy lesson because, well, you got to know a lot of postulates and you got to know there's a lot of fundamentals that you got to understand before you can go about proving things. So we're going to kind of introduce what proofs are here as a concept. We're going to go over a lot of postulates, do a few examples with those postulates, and then in part two, we'll actually start proving some theorems using those postulates. And so we're going to be, like I said, we're going to be talking about, how proofs work and deductive reasoning for proofs. So how is deductive reasoning used to prove a theorem? And using reasoning to prove these theorems. So again, this is going to be vocab heavy. There are going to be a lot of terms in this lesson, including postulates. So here we have various types of angles that we'll learn or review, types of proofs, what a proof is, and a theorem, and like I said, there's two types of proofs that we'll study. So what is a proof? A proof is a convincing argument that uses what we call deductive reasoning. So deductive reasoning is, when you deduce or conclude something. So for example, deductive reasoning usually uses known facts or previously known facts or statements that we know are true. And using that knowledge, we end up concluding that something else is true or false based on prior knowledge. So, for example, let's suppose that you know that if say Jimmy gets a D or an F on a test, let's say he gets something below a C, and we know that if he gets below a C, then his parents will ground him. Okay, so we know that to be a fact, that if that were to happen, his parents are going to ground him. So given that knowledge or that fact, suppose that Jimmy comes home and he gets an F on his test or on his class. Well, then what's going to happen to Jimmy? Well, we know what's going to happen to him because based on the previous knowledge, based on the fact that I stated earlier, we know that he's going to be grounded. So we deduced that he was going to be grounded based off of that prior knowledge or that fact. Okay, so that's known as deductive reasoning. So using facts or previously known truths in order to make a conclusion about something. So in proofs, we're going to be using various facts or postulates in order to prove something else, whether it's true or not. Okay, so there are several ways in which we can organize and present a proof. So there are two different types of proofs that we'll talk about. In another lesson, we'll introduce a different type of proof. But for now, we're going to be concerned with these two, the two-column proof and the paragraph proof. So a two-column proof is exactly what it sounds like. There are two columns. The left column is usually the column of statements. The right column is the reasons for those statements. So the statements are the truths, the prior truths that we know. And then the column is, why we use those statements. And basically, putting a bunch of statements and reasons together is going to lead to the final conclusion or the proof. And so this is an example of how a two-column proof looks like. You can see on the left are the bunch of statements, and these are various postulates and things like that we kind of put in steps in order to lead to a final conclusion. And on the right are the reasons for those statements on the left. Each statement, notice, has a corresponding reason, and that is based on some known fact or theorem. And this is why we call it deductive reasoning. So the second type of proof is a paragraph proof, and it's basically the paragraph version of the two-column proof. So instead of having the two columns, you just have the statements and the reasons, and you put them in a paragraph. So you put them in sentences. So you can convert a two-column proof to a paragraph proof and vice versa. And below is an example of a paragraph proof. The details of the proof are not important at this point. I just wanted you to see an example of how it looks like. Usually in a proof, you have a given statement, and then you want to prove something. So you have something that is given, and then you have something that you want to prove. And so you got to use deductive reasoning to get from the given to the proof. So a theorem is a conjecture that is proven. So we'll be proving some theorems in this course. For example, the Pythagorean theorem is a well-known theorem. All right, so another theorem that we'll actually look at, and that will, at some point we'll be able to prove some of these theorems, but not all of them, but a good amount of them we'll be able to prove. So the vertical angles theorem. So states that vertical angles are congruent, which means that their measures are the same. So what are vertical angles? So vertical angles are angles that are opposite of each other, and they're usually formed by intersecting lines. So for example, if you look at this example below, you have two lines that intersect here, and they intersect at this point in the middle, right? And so the vertical angles are the angles that are formed from that intersection. And they have to be opposite of each other. So if you look at 1 and 2, well, those are vertical angles. They're opposite of each other, right? 1 and 3 in this case will not be vertical angles because they're not opposite of each other. So in this case, 1 and 2 are vertical angles, which means that their measures are the same. So that means if 1 is 30 degrees, then that means 2 has to be 30 degrees. And because their measures are the same, that means the angles are congruent. And so this is the vertical angle theorem. Basically states that if you're given vertical angles, then that means that those two angles have to be congruent. Okay, so another type of angle pair, aside from vertical angles, are adjacent angles. So looking at the same example, remember that the vertical angles are opposite of each other, so that would be 1 and 2. In this case, adjacent angles are actually next to each other, and they share a common side and a vertex. So for example, 1 and 3 would be adjacent angles. So they have to share a common side and a vertex, as I mentioned earlier. The vertex is the point in the middle, and then the side is the ray that I highlighted in red. All right, so adjacent means next to each other. They share a common side and a vertex. Vertical means opposite of each other. So angle 1 and 3 are also known as what we call supplementary angles. So you may or may not remember what that is, but supplementary angles add up to 180 degrees. So in this case, 1 and 3 are adjacent angles, but they're also supplementary angles. They add up to 180 degrees. Anything that forms a straight line, so where you have two pieces going to a straight line, form a 180 degree angle when put together. In this case, angle 2 and 3 are also supplementary angles, and they're also adjacent angles because they share that common side. In this case, I'll highlight it here. This is the common side that they share, and this is the common vertex that they share. Okay, so again, supplementary angles add up to 180. So for example, this line right here, this angle is known as a straight angle. So straight angles add up to 180 degrees. So if I had an angle that goes here, and this angle was, say, 30 degrees, well, then this other angle has to be 150, and those two have to add up to 180, okay? All right, so a linear pair is a set of angles that they're adjacent and they're supplementary. So they have to satisfy both conditions. So in this example below, you'll see that angle 1 and 2 share a common side, which is this side right here. They share ray OB in this example. And they share a vertex, which is O, and they're supplementary, so they add up to 180 degrees. So we know that this angle is 180 degrees, that total angle. And so we call them a linear pair. So in this example, angle 1 and 3 form a linear pair. Angle 2 and 3 form a linear pair. Because they're adjacent, as we mentioned earlier, and they're also supplementary. You can also think of a linear pair as a set of adjacent angles formed by intersecting lines. So for example, this is formed these are intersecting lines. If you drew this like a straight line extended out, well then now that becomes a line, and then those are intersecting lines. Okay, so a bunch of vocab here. So again, we said that supplementary angles add up to 180, whereas complementary angles add up to 90 degrees. So supplementary is 180, complementary is 90. Okay, so looking at an example real quick, just to identify the terms that we just mentioned. looking at that diagram, we know that angle 1 and 2 are adjacent because they share, they share a vertex and a side. 1 and 3 are also adjacent because they share, this side. And then 3 and 4 are adjacent because they share this side, right? And so those are examples of adjacent. Angles 3 and 4, they're complementary because notice that they add up to this right angle. So again, let me highlight that. This right here is a right angle. It's 90 degrees. And so angle 3 and angle 4 add up to 90 degrees when you put them together. The angle 1 and 2 are supplementary because they add up, if you put them together, they add up to 180 all together. Angle 1 and 2 also form what we call a linear pair because they're adjacent, they share that common side, and they add up to 180. All right, so let's look at an example using the vertical angle theorem. So remember that the vertical angle theorem states that if we have two angles that are vertical angles, then that means that they must be congruent. So if we look at these two angles here for part A, they are vertical angles. They're opposite of each other and they're formed by intersecting lines. So we know that those angles have to be equal to each other based on the vertical angle theorem. So based on the VAT, the vertical angle theorem, we know that those two angles across from each other have to be equal. And so we're going to go ahead and set them equal to each other. And there we go. We set them equal to each other. And then we got to solve using a little bit of algebra. So we're going to subtract 4x on both sides. We got 2x minus 45 equals 5. Then we're going to simply move the 45 over to the other side. So we have 2x equals 50. And so 2 times 25 is going to give us 50. So x has to be 25. You could just divide by 2 on both sides. And so we have x equals 25. All right, so we got the x value. Now, so we want to find the value of x, so that's good. And we want to find the measure of each labeled angle. Okay, so we have x equals 25. Now let's figure out, well, we know that if we find one, we find the other one because both angles are the same. So let's just plug it into one of them. Let's plug it into 6x minus 45. So if we plug in x into this statement here, then we have 6 times 25 minus 45. So in this case, 6 times 25. So 4 times 25 is 100. And so and then you have 2 more 25. So this will be 150. And then 150 minus 45 is 105. All right. And so we know, I don't even have to check the other one. I know that the other one's going to be 105 because by the vertical angle theorem. All right, so again, so doing the vertical angle theorem for part B, these are definitely vertical angles. They're opposite of each other, so they have to be the same. So let's set them equal to each other and solve. And so now let's move this 5x over to the other side and subtract it. We have 3x minus 20 equals 37. Let's move the 20 over by adding. And we have 3x equals 57. And we can simply divide by 3 on both sides. Okay, so 57 divided by 3 should be 19. So we got x equals 19. Then we plug it into one of them. So let's plug it into this one, 8x minus 20. So we have, 8x minus 20. Plug that in. We have 8 times 19 minus 20. Okay, so what we're gonna do is, I'm gonna do this mentally, but you can use a calculator. 19 is almost the same thing as 20. So 20 times 8 is 160, and then we take away one extra 8, and so this is gonna be 160 minus 8. That's 152, and then minus 20. And then that's going to give us 132. So 132 degrees. And so both angles are 132 degrees. All right, so that's how you use the vertical angle theorem to solve for an unknown. Okay, so now we're going to talk about postulates, a bunch of postulates. So we discussed the vertical angle theorem. We talked about like the different types of angles to give you a background of angle pairs. Now we're going to actually study some postulates. Some of these we actually have already studied in the course so far. So you may recall some of these postulates. So the segment addition postulate, and that's actually one of the first postulates we discussed. So the segment addition postulate means that if you have three points that are collinear, meaning they're on the same line, and then that means, so for example, for this example, if we have A, B, and C, so these are collinear, and B is between A and C, well then you can just add. So you have AB plus BC equals AC. So this first one plus this second one gives you this total, which is 3. So 1 plus 2 is going to give us the total, which is 3. So that's the segment addition postulate. The angle addition postulate is the angle version of that. So if you have these two angles, you can add them together and form a third angle. Okay, and that's really what this angle postulate addition postulate says. The linear pair postulate states that if two angles form a linear pair, then they're supplementary. So we mentioned what a linear pair was. A linear pair is usually adjacent, meaning they share a side, and they also add up to 180. So that's what this kind of says. Is if two angles form a linear pair, then they have to add up to 180. So that's basically what that postulate says. And this is an example. So these are adjacent. They form a linear pair. And remember, the definition of a linear pair is basically roughly what I said earlier, but really you can think of a linear pair as formed by intersecting lines like this. So they're adjacent and they're formed by intersecting lines. And so these two lines intersect, these are adjacent, and so by the linear pair theorem, they have to add up to 180, okay, based off of this. All right, so those are some of the postulates, and you have to kind of devote those to memory and kind of know those. And you, with experience, you'll be able to use them readily. So now let's talk about some properties. There's a bunch of properties to discuss here. A lot of them you may remember from algebra. So we have the addition property of equality. If A equals B, then if you add the same number to both sides, you're going to get something that is also equal to each other. So if I have A equals B and I add the number C to one side, well, then I have to add the number C to the other side. And that's because of the addition property of equality. So here's an example. Let's say X is equal to 5. Well, then if I add 1 to both sides, if I add 1 to the left side, then I have to add it to the right side, right? And in that case, I get X plus 1 equals 6. All right, the subtraction property of equality is the same version. It's the same thing as the addition property, with the exception that it's the minus operation, right? So we're subtracting a same number on both sides. So for example, X equals 5. If we were to subtract 1, then we would have to do it to 5. So this should say 5. And 5 minus 1 would be 4. So in this case, we would have X minus 1 equals 4. And that's the subtraction property of equality, subtracting the same number. The multiplication property, you're multiplying the same number on both sides. So for example, X equals 5. If I multiply by 2, then that'll be 2X equals 10, 2 times 5. If the division property is a division version, so again, if I divide by 2 on both sides, on one side, then I got to do on the other side. Now the substitution property, if A is equal to B, then you can take A and substitute it for B into any equation. So let's look at this in action. So let's say we have X equals 5, and we know that Y is equal to X plus 1. Well, since we know that X is equal to 5, then we can take that value of 5 and substitute it in for X in another equation. And so now X is now replaced with 5, okay? And that's known as substitution. You're substituting X for another number. All right, distributive property, you may remember this. So you're going to distribute the number on the outside to both terms on the inside. So if you had X times 2 plus 5, then you would have to multiply X against everything and share it or distribute it. And in this case, you would have 2 times X and then 5 times X. And that's the distributive property, is when you distribute the number on the outside and you multiply it against everything on the inside. Now this has to happen when you have a plus or a minus inside the parentheses. You're multiplying by a number on the outside. And then the reflexive property is, it kind of seems weird that we're using properties like this, but A is equal to A. So it literally is saying if a number is equal to itself, basically is what it's saying. So 5 is equal to 5, 1 is equal to 1, etc. Okay, so very simple property, but it's known as the reflexive property. And then the symmetric property states that you can reverse the order in an equation and it still represents the same thing. So if A is equal to B, then that means B is equal to A. So for example, if X is equal to 5, then that means 5 equals X. The transitive property states that if A is equal to B and B is equal to C, then that means A has to equal to C by the transitive property. So let's show you an example. So let's suppose X is equal to Y and Y is equal to 5. Well, then that means X has to equal to 5. Okay, so if X is equal to Y and that same Y is equal to 5, well, then basically you can just get rid of the Y and say that X is equal to 5. Okay, and that's known as the transitive property. All right, so now let's look at this example. So we want to solve this equation for X, but in doing so, we want to list all the properties of equality for each step. So let's look at the first step. Well, first off, we want to use the distributive property, right? So we want to distribute the 4 to the X and to the negative. Well, then 4 times X is 4X, and then 4 times 2 is 8. So that's what we get for the bottom. Now we're just simplifying that, right? So 4 times 2 is 8. So we just simplified. So that step is just simplifying. And now what we're going to do is we're going to basically move the X over to the other side. And so we're going to subtract X on both sides, which means we're going to be using the subtraction property of equality. And now we got no more X's on the left side, right? Because that X on the left side canceled out. And so we're going to simplify this. And we know that 4X minus X is 3X. And then X minus X cancels. And so now what we're going to do is we're going to move the 8 over to the other side by adding it. And that's known as the addition property of equality. And so now we simplify that because the 8 and negative 8 cancel. And then 7 plus 8 is 15. So we simplified. Then the last step, we're going to divide by 3 on both sides, and that's known as a division property of equality. So these are things that you normally do whenever you're solving an equation in algebra. You're constantly using these properties, right? But you're not necessarily naming them. And here we're actually going through that entire process and naming each step. And so now we're going to do a little bit of simplifying because the 3's now cancel, and we have 15 divided by 3 is 5. And so we're done solving for X, and we listed all the steps. All right, so now we're going to look at some definitions. So we talked about some postulates, some properties, and we use those properties to solve an algebraic equation. And now we're going to talk about some definitions, all right? So again, all of these things we're going to put together for proofs. Especially in part 2 when we're going to use some of these. All right, so some definitions to know. Let's talk about the definition of the midpoint. We actually talked about this in lesson 1.3. So the midpoint, remember, is literally the middle of a line segment. So if P is the midpoint, so then that means AP is equal to PB. So basically we have a line segment, we cut it in the middle. That's the midpoint. But when you cut it in the middle, that means you have 2 equal pieces on each side, right? 1 on each side. And so in this case, AP is the same as PB. So that's the definition of the midpoint. So if you have a P in the middle, then that means the segments on each side are the same. Now the segment bisector, remember bisector means you cut in half. So segment bisector means that you're cutting a segment in half. So if K intersects AB at the midpoint, then that means K bisects AB. And so here K, the line K is a bisector. It's just a line that cuts it in half. And basically it's similar to the midpoint, but instead of it being a single point, it's just a line. So it's a line that looks like it's physically cutting it. And so if you have a line that that intersects it at the midpoint, that means it slices it in half. All right, so perpendicular lines, remember, are lines that intersect at a 90-degree angle. So the definition of perpendicular lines, so if two lines are perpendicular, they have to form right angles. So in this case, for this example, if you look down here with the intersecting lines here, these two intersect and they form right angles. And so they're perpendicular. So in this case, we would say line K is perpendicular to line AB. There's a symbol for that. The symbol for perpendicular is this guy right here. It looks like an upside down capital T. So it's line K is perpendicular to line segment AB, or line AB. So keep that in mind, that symbol for perpendicular. All right, so if AB is equal to CD, then that means line segment AB is congruent to line segment CD. And that's just a definition of congruence. So if two segments are the same length, then that means the line segments have to be congruent. Okay, so some of these are kind of obvious, but we have to put them into a definition. And then the definition of congruent angles, well, if the angles have the same measure, then that means the angles are congruent. And so that's what we were saying here. If the angles are congruent, then the measures are the same. And then the definition of angle bisector. So if you have AB bisecting an angle, let's call it CAD, then that means that the angle on both sides is equal, are congruent. So let's show you that picture. So in this case, AB bisects this angle, it cuts it in half, which means that this top angle and this bottom angle are identical. So CAB and BAD are congruent. And then, the definition of complementary angle and supplementary angle, we kind of talked about it. But complementary angles, remember, if they're complementary, they have to add up to 90 degrees. So that's what this statement says. The measure of angle A plus measure of angle B is 90 degrees. So, for example, if we have this is A and then this is B, well, then those two angles have to add up to 90 degrees. For supplementary, if we have something like this, where this is A and this is B, well, measure of angle A plus measure of angle B has to add up to 180 for supplementary. And then the last one is the linear pair. So remember, the definition of linear pair is when you have a set of adjacent angles that are formed by intersecting lines. So the lines have to intersect like this, for example. And then so if this were angle 1, 2, 3, 4, well, then angle 1 and 4 are linear pair, angle 1 and 3 form a linear pair, and angle 4 and 2 form a linear pair. All right, that is it for the properties and definitions. We're actually going to finish this up in part 2. Like I said, this is a lengthy lesson because we have to introduce a foundation, which are the postulates, definitions, etc. And then we'll continue this and actually do some proofs in part 2. Thank you guys. I hope you learned something from this lesson, and I'll see you in the next one.